Good morning everyone. Here we will continue the congruency of triangle. This one is exercise 10.2 and the next rule of congruency of triangle is angle side angle, that is ASA congruency. See the statement: when two angles and the included side of a triangle is equal in measure to the two angle and their included side of another triangle, then the triangles are congruent. Okay, so here included side, what is the meaning of included side? Okay, try to understand the meaning here. See, we are saying that this one and this angle A and this angle B that we are considering here, then the included side is the side in between those two angles. That means if we are considering angle A and angle B, then for angle A and B, the included side is the side AB. Okay, this side. Okay, see here a green mark is there, so this side we are considering. When we are considering those two angles, that means A and B, then the included side will be AB. Okay, so like the same way here we are considering R and Q, the angle R and angle Q, then the included side will be in between those two. Okay, in between those two angles, that means here this RQ is the included side. Okay, so here the statement is given that if two angles are equal to two angles of a triangle is equal to the corresponding angle of the other triangle. So here we are saying that this angle A, the given condition that we are taking here, that A is equal to the angle R. Okay, and one more thing, that B is equal to angle Q. So two angles are equal. Here this angle A, first angle A is equal to R and the second one B is equal to Q. And one more thing is here, the side. Okay, the included side in between A and B, that is this AB is equal to the side in between R and Q, that is RQ is equal. Okay, that means they are equal in length. So here the statement is given. See, their included side, that is the side between the two angles, is equal. So here the green, above the green border, you can see AB is equal to RQ. Okay, and remember that when we found A and angle R are equal angle, that means the point A and the point R corresponding to one another. That means whenever we will take point A for this triangle ABC, at the same time we have to take angle R for this triangle. Okay, so A is correspond to, the point A is correspond to R. Like the same way this point B is correspond to Q. So that's why here we have taken AB na, AB is taken, so here it is RQ. AB is equal to RQ. See, you can understand by the colors given here. Okay, the point A is orange color. Okay, so here the R is also orange color. So that means those two are corresponding to one another. Here point B is green. Okay, dark green. Q is also dark green. So whenever we take A, we will take R. Whenever we take B, we will take Q. So AB is equal to RQ, like that. Okay, so then by the ASA congruency, see here ASA congruency, here you can take the order also. See here, this one is angle, the first angle. Okay, so that means angle A for angle here. Okay, then this one is the side and this one is the angle. Okay, so angle side angle with the proper order is equal to, here from here we can take angle side angle. Okay, so by ASA congruency, that means angle side angle are in order, the side is included in between those two angles, and this is the angle side angle congruency rule. Okay, so by using this rule here, if we have those condition, then directly we will say by using this rule those two triangles, like see here the name is taken. See the name ABC is taken, triangle ABC. Here you can see here in this line triangle ABC, sorry, it is ABC. Here you can see, okay na, here triangle ABC is equal to triangle R. In the place of A it is R, B in the place of B it is Q, so RQ, and then finally P is left. So triangle ABC is congruent to triangle RQP. So this is angle side angle congruency. Now see the next congruency rule. It is angle side congruency. Okay, and angle side are in the order. That means we are taking first one angle, then second, then for the second angle, and then the side, then the very next side I'm telling. Okay now, so see the statement first. When two pair of angles and the pair of corresponding sides are equal, then the triangles are congruent. Okay, here in the given figure, see, O is equal to, this O is equal to P. By color you can easily understand. So that means O become the corresponding point, O and P become the corresponding point to one another. Like the same way, N is equal to Q. So whenever we take N, we will take Q. Okay, so if it is O N, then it is PQ. But here two angles are given equal, so we are considering here this angle O and this angle N, and then the very next side is NM. So again this NM is given equal to QR. So here we are considering P, then Q, then the very next side QR. Okay, so P, Q and QR, so those are equal. Then by the angle side angle, see the order here. Okay, this one is the angle, this one is the angle, and this one is the side. Okay, so by angle side, here we have the same order. Okay, angle and then side. So we will say that by the angle side congruency rule, those two triangles O and M, you can see the order here. Okay, O and M is congruent to triangle PQR. Okay, O correspond to P, N correspond to Q, and this Q, this M is correspond to, this M is correspond to R. So it is it is O and M is congruent to PQR. Now see the next page. This one is the next page. So we will start the exercise 10.2, the first and for the second question. The question number 1 and 2 hint is given. See, you can answer this one. The question is asked to you, and for the reason you can mention the rule of congruency that used there. Okay, it will be either angle side angle or angle side. So you have to choose which rule you are choosing, and you have to also identify the side which is equal. So just read the question and you can answer. For the question number 3, read the question and you can answer this one, and you have to mention the reason that by angle side or by side angle. Okay, those two rules by those two rules we can say that if two angles and a side are found equal in two triangles, then those two triangles are congruent to one another. This is explanation for question number 3. Okay na? So you visit the question, read the question, you can easily understand. Now question number 4 is solved here. You can see this one is the picture that for question number 4. See, the given condition is given AD is the median, this one AD, and this one is MED. This AD is the median, falls on the side BC. Okay, so the median will bisect, the median will actually divide equally the base. Okay, so here BC is divided by two equal halves, so BD is equal to CD. Okay, so here we have taken this BD equal to CD. Clear? Now whenever we are seeing that, we have to prove the part like BM is equal to CN, that we have to prove, that is given in the question. So before, whenever we see the part that we have to prove, we have to use the idea to find out the congruency of two triangles, and which are those two triangles, those should be proved congruent. Okay, to get this BM and CN. Okay, so we can easily identify that those two triangles here, this triangle and this triangle, from the picture you can easily identify these two triangles are to be proved congruent. Then after we can get this BM and this CN. Okay, then we will say, so first start, we have BMD. Okay, it is also given, this BMD is equal to C and D. This BMD and this C and D both are perpendicular on this AD. Okay, and the produced side AD. Okay, so those two angles are equal to 90 degree. Here the green mark refers 90 degree. Okay, here the 90 degree of the written is green. Okay, na? So this BMD is equal to CND is equal to 90 degree. Both are perpendicular. Now one more, see this one more angle, angle MDB. MDB. Okay, MDB. So we are focusing on the point D. Okay, na? And here also NDC. So MDB and NDC, those are the vertical opposite angle. This angle, okay, and this angle, those are vertically opposite angle and those are equal. So we found two angles are equal, then one side is also equal. Yes, see this one BD is equal to CD. So if you say BD, then it is equal to CD. Okay, so this is because of this AD is the median. Okay, so by this we got one angle equal, another angle is equal, and one side is equal. So by angle side congruency, those two triangles are proved congruent to one another. Okay, and if those triangles are found congruent to one another, then we know that the corresponding parts of the congruent triangle are equal. So we have the corresponding side, this one. Okay, CPCT means corresponding part of congruent triangle. So here the corresponding side BM must be equal to CN. Okay, when those two triangles are congruent. So this is proved. Now see the next question number 5 you can solve. Okay, it is same as question number 4. So that's why the hint is given for question number 6. And the hint, see first the hint. Okay, hint is given that so the alternative angles are equal, because in the question it is given the parallel sides are given. Okay, na? So you know, you can easily identify the alternative interior angles, and properly the names are also given that which of the angle you have to show equal the alternative interior angle, like this one BAC is equal to DCA, and one more pair, that is BCA is equal to DAC. So if you take those two angles, you will get one side common. Okay, one common side you will get in those two triangles. Okay, and then after angle side angle, by using this rule, this congruency rule, angle side angle, you can prove those two triangles congruent. Okay, so try to solve this one by your own. Okay, and see the question solution of question number 7 is given, so you can get the idea from this also. Okay, so try to understand the question number 7. Now see, in question number 7, this one is the figure. Okay, and the given condition is that this BC is parallel to DA. Okay, so this BC is parallel to DA, that means we can find the pair of alternative interior angle. Okay, so alternative interior angles are equal. So which of the angle are equal? So this one we can say this ABC is equal to this ABC is equal to, see, this ABC is equal to BAD. Okay, that means these two angles, okay, this one and this one, these two angles are alternative interior angle and those are equal. And similarly we can say that this angle, see this okay, this one is BAC. So in the place of BAD we can write OAD. Okay, because O is on the same point. Like the same way we have taken ABC, na? See here ABC is taken, so in the place of ABC we can write this one is ABC, na? From starting from here ABC, so we can take only OBC. Sorry, this one is we can take OBC, like that. Okay, so the other pair of interior angle, see here it is given. So first we have one pair of interior angle, and then the side is shown equal because we are trying to use the angle side angle. So first one angle is taken, then take the included side. Okay, this angle is taken, na? This angle is taken, and here this angle is taken, so we will take the included side, that is from here to here, that is BC. Okay, BC, and this angle is shown equal, so we will take AD. So that's why I have written here, see it carefully. See, this BC equal to DA, it is given. Okay, and this BC is equal to AD, that I have written. This is only because I want to maintain the order of the points. Okay, I have taken the corresponding point in their places. That means whenever we take B and C, then B be found as the corresponding point of A, so we will take AD. BC equal to AD, it is given. So one angle and one side are found equal. So one more angle, this one is all the alternative interior angle, so we will say it is DCB, like this one. See, this angle and this angle. So one is DCB, so we can write OCB. Okay, so it is OCB is written, and the other one is here you can see this angle na, this angle. So this angle is marked as CDA na. So CDA, in the place of CDA we can write ODA, ODA, like that. Okay, so one angle, one side and one angle are found equal. So by using the rule angle side angle, we can say that triangle AOD. Now see the order carefully. Okay na, see this order AOD. Okay, and A is found the corresponding point as B. So when we take A, we will take B, and O is common for both the point. Okay, and here the alternate vertical opposite angle are also equal. So for both the triangle, the angles at the point O is equal, is found equal, this one and this one. So directly we can say here, if it is AOD, then we will start with BO, then finally it is C. Okay, so triangle AOD is equal to BOC. Then we have to prove that O is the midpoint of AB as well as CD. So here by we can use the CPCT, that means corresponding part of congruent triangle, and we are considering here the corresponding sides. Okay, so if it is AO or it is OA, then we can say it is OB. OA is equal to, sorry this one no, OA is equal to OB, like that. Okay, so OA is equal to OB found, and if OA is equal to OB, then OB the midpoint of AB. Okay, in the same way OC, this OC is equal to OD, then we will say that O is the midpoint of CD also. So this is proved. Okay, now see the question number 8. For 8, hint is also given. So see, the lengthy hint is given. So I mean to say that this hint is helpful, and you can easily solve the question by seeing the hint. Okay, so here the sum of triangle ABC. Okay, the sum of BCD, angle BCD and BCA. Okay, because this BCD and BCA is equal to, the sum of these two angles is equal to the sum of ACD and ADB. This is only because this BCD is given equal to this ACD, and this is given equal to this ADB. So when two equals are added, okay, so this part and this part, these two are equal na. So if those are added, then their sum will be also equal. So that's why it is written here their sums. Okay, the sum of this angle BCD and BCA is equal to the sum of ADC and ADB. If you see the figure, you can easily understand. Okay, so angle ACD is equal to angle BCD. So that is the required thing here, okay, to prove the triangles congruent. So this ACD is must needed, this ACD is equal to BCD is must needed to prove the congruent. Okay, then see the side is given common, CD is DC, CD DC means same side. Okay, and the final one ADC and is equal to BCD, it is given. Okay na, so you can use the angle side angle congruency rule, and you can found those two triangles congruent, and then after proceed the solution. Now see the question number 9. Here you can see the figure is given. Okay, so first for the bit 1, we have to prove those two triangles. You can easily identify the two triangles. Okay na, see this one is the yellow colored triangle, and this one is the pink colored triangle. Okay, it will exist that much. Okay na, those two triangles are to be proved congruent. So this is the first bit. Okay, see the given condition. Given condition is BE is equal to CD. Okay, so if it is BE, but here I have taken EB is equal to CD. EB is equal to CD, because later we will find this B is correspond to C and this E is correspond to D. Okay, so that's why I have written here EB. EB is equal to DC. Okay, you can take also. Now see, the next given part is ABC, angle ABC is equal to ACB. That means this angle, I'm sorry, this angle, okay, this angle is equal to ABC is equal to ACB. Okay, if those two angles are equal, so this E is on the line AB, so you can start from EBC, and here we can start from DCB. So this EBC is equal to DCB. So here what we found, this point B is corresponding to point C, because whatever the angle is made here at the point B is same as, is equal as the angle made at the point this C. Okay, so EBC is equal to DBC. Okay, and the common side you can see here, BC is equal to CB. So here we are from, for this triangle, okay, now for this pink color triangle, we are starting with EB and then going to C. So it is BC is equal to, here for this yellow color triangle, DCB. So we will from D to C then to B. Okay, so CB. So it will be BC is equal to CB. Both are common sides, same side. Okay, so their length is also same. So we will find one angle and one side. So by, so it is yeah, one side, okay, one angle and one side. So by the side angle side congruency rule, those two triangles are found, congruent to one another. Okay, so here we are taking, see, here we are taking first this angle, okay, sorry, this side we have taken na. So we have taken this side EB, then after this included angle. So here also the concept of included angle is coming, okay na. See here we are taking this side and this included angle we are taking, then after we have taken this. So side first taken, then angle is taken, then side. Okay, so see the order, okay, this order is followed. So side angle side, by this by the congruency rule, side angle side, those two triangles are found congruent here. So as those are found congruent, so we can take the congruent part, corresponding part of the congruent triangle. That means here we are taking first the corresponding side EB, this one, this side EB, this EB is taken equal to this DC, and the corresponding angle CEB. Okay, so this one CEB. Okay, so this one is equal to BDC. Why? Because in the next bit we have to take to another triangle, prove to another triangle congruent. Okay, and where those two things are needed. Okay, now, so that's why from this part we have taken those two. Okay, now see the next page. See, for the bit 2 we have to prove those two triangles congruent. See, those two greenish colored triangle, the green colored triangle you can see, okay, in the picture you can easily identify those two triangles. So as here for those two triangles BOC, see this one BO, so this one is BOE, okay na, this one is BOE actually. So BOE is equal to COD, okay, COD. Remember that this one is BOE, okay na, BOE, and it is equal to COD. So they are vertically opposite angle, and this one CEB is BDC that we have found just earlier. Okay, I have shown you, and as it is CEB, so for this triangle we can start from O. So OEB is equal to ODC. So as in the previous bit we have shown this one, these two angles are equal. So here we are taking those two angles. So one angle and another angle, this angle are shown equal and this angle is also shown equal, and we know that this EB that we are taking from the starting part, okay, this EB is equal to DC. So angle, this one angle, okay, this one angle and side. So angle, side, by this congruency rule those are found congruent. So this one is the proof of bit 2. Okay, see here, okay, here you can see. So bit 2 is proved. Then if we prove those two triangles congruent OEB, we are starting from OEB, so here also ODC. So those are proved congruent. Then their corresponding part are also equal. So the corresponding part of congruent triangle, we are taking the corresponding side OB, that is the OB is equal to this OB. Okay, so this OB, it is OC. So OB equal to OC. OB is equal to OC. This is found. Okay, and this is the third bit. So all proved. So this is it. Thank you class. Have a nice day.